Another thing that we can use our limit definition of continuity to do is we could take a function where maybe there's an unknown value and we could figure out what value we would need it to be in order to make the function continuous. So let's consider the function g of x equal to, and it's going to be a piecewise function where we're going to say 2x squared for x less than or equal to 2, and we're going to let it be ax plus 6 for x greater than 2, where a is some unknown numeric value. So in this particular situation, we want for a to be a real number. Well, the question that we're going to ask ourselves is, what is the value of a that will make g of x continuous on the interval from -infinity to infinity? If you take a look here, I've got just a simple quadratic right here, a linear piece right here. I would have no break in continuity except for I need to kind of force them to be continuous at x equals 2, because that's where my function redefines itself. So in order to be continuous at x equals 2, that's the only thing right now that I have an issue with, is I need to figure out what value of a is going to make it continuous at x equals 2. Well, if it's continuous at x equals 2, then what would be true is that g of 2 would equal the limit as x approaches 2 of g of x. And so let's figure out what these things are. Even though I don't know what a is, I've established that a is going to be a real number for us. Let's figure out what these things are and see if we can't figure out what a would need to be in order to make this true. So I know that g of 2, if I substitute 2 into this function for x equal to 2, I would substitute it into 2x squared, and 2 times 2 squared is 8. So I know that g of 2 is 8. And so in order for this function to be continuous, the limit as x approaches 2 of g of x is also going to have to be 8. So let's take a look at the one-sided limits as we approach 2 of g of x. Well, as I approach 2 from the left, less than 2, again, I can evaluate that with direct substitution. It comes out to be 2 times 2 squared, which is 8. So I'm good there. And then when we look at the limit as x approaches 2 from above of g of x, well, for values greater than 2, I would substitute 2 into this linear piece. And so if I do that, I get a times 2 plus 6. So g of 2 is 8. The left-hand limit is 8. The only way that this could be continuous, so in order for the limit as x approaches 2 of g of x to equal 8, which is what we want, the left-hand limit already equals 8. So that means I need this right-hand limit right here, 2a plus 6, to equal 8. And then we're back here on the first day of Algebra 1. Subtract 6, divide by 2. And so the value that would make this function continuous at x equals 2, I would need for a to equal 1. And in fact, if you were to look at this function as 2x squared for x less than or equal to 2, and 1x, or x plus 6 for x greater than 2, and you applied our definition of continuity, you would see that, yeah, that function is continuous at x equals 2. So the value I needed for a was 1.